Hello there, my name is Sibusiso, but you can also call me Coach Sbu. Welcome into the Maths Paris tutorial. In this video, we're going to be going through what I would like to call a March exam preparation. So what is a March exam preparation? So this is basically going to be a series of videos where I explain to you some of the topics that you might have studied into your school to help you prepare for the Term 1 exams, hence the word March exam preparations. Now in this video, we're going to be covering a grade 11 Euclidean geometry. So without wasting any further time, let us jump in right into these type of questions. Now here, we are given a question, and this is a Euclidean geometry. So let's go ahead and just go right into it. So the first question here, we are given question 3. And the 3.1, it goes as follows. So it says we need to complete the following questions. So the question here, it says a line or the line drawn from center of the circle perpendicular to a chord, and then after that it has those dotted lines. So basically here we need to finish that sentence. So to finish that sentence, we would say that the line drawn from center of a circle perpendicular to the chord bisects the chord, right? Okay, so that is the first question done. And then now we're gonna go into the second question. So the second question, 3.2, it says the figure below, AB and CD are chords of the circle with center O. Now OE is perpendicular to AB. CF is equals to FD. OE, it is 4 centimeters, OF is 3 centimeters, and CD, it is 8 centimeters. Now when it comes to Euclidean geometry, what is the very first important thing that you're supposed to do? Now, the very first important thing that you're supposed to do is to actually make sure that you take note of what you are given. Now, here we know that we are given that right here as given. So here we are given that number 1, OE is perpendicular to AB. Now, if OE is perpendicular to AB, what does that mean when it comes to angles? So basically, it means now OEA or angle OEA, it is going to be the same as angle OEB, and both of them will be equals to 90 degrees. Now remember, when you're dealing with Euclidean geometry, we don't focus on sides, right? Euclidean geometry in grade 11, we studied the angles. So now here we were told that the line of OE is perpendicular to the line AB. Then now we conclude that the angle that they make, it is 90, right? So now what's the next thing that we give it here? So the next thing that we're given is that we are given that CF is equals to FD. So with this one, I would like to just go there and then show it like that, right? So what does this mean? If CF is equals to FD, basically this means now angle F is going to be the midpoint of CD. And because of that, then we'll have a theorem there that states that a line drawn from a center to the midpoint of a chord, that line, it is going to be perpendicular to the chord. So that is something that we can basically conclude with that, right? So here I can just say here angle F is at midpoint, right? So this is going to be something that I'm going to be using later on. All right, now what else are we given here? We told now OE, it is 4 centimeters, so I'm going to go ahead and write that in there. And then OF, it is 3 centimeters, so let me also write that in there. And then CD, it is 8 centimeters. Now here, because of we're given already that we have CF and FD, if they tell us that CD, it is 8 centimeters, this basically means now here, because of we are now aware that we have what? We have CF being equals to FD, and then this basically means now CF, it is going to be 4 centimeters, and then FD, it is also going to be 4 centimeters, right? So with that written down, we can then now go into our first question. So let's go ahead and basically go through what the first question is asking. So the first question here, it says we need to calculate the length of OD. So OD, as you can see, this is going to be the radius here, like that. So the radius here, we're going to say OD squared is equals to, oh sorry, before we get into that, remember here we still given this, right? But we haven't first confirmed that this is actually what? Perpendicular, right? So to answer this, the first thing that we need to do here is to actually say that OF, angle OFD, it is equals to 90. And then because of that, I'm going to write the reason here. I'm going to say line from center to midpoint chord. So to midpoint chord. Now this basically means now here we can see that OF is perpendicular to CD. Now because of that, then this means now in triangle OFD, if we make that a triangle, then OD squared will be equals to OF squared plus FD squared, right? Now OD squared will be equals to, the value for OF, it is 3 squared plus, and then FD, it is 4 squared. So now press this on your calculator, we will have 3 squared plus 4 squared, giving us 25. So here we'll have 25 as OD squared, and then now we're going to put the square root both sides, and then OD, it is going to be 5 centimeters, and then that is how we find the value for OD. Now let's go ahead and look into the second question, 3.2.2. So now the 3.2.2, it says now let's calculate the length of AB. Now going back into where we have our information, what we're going to do here is you're going to insert that OD there so that we can see the recent updates. So we see that we have 90 there, and then we know that this is 5 centimeters, and so now we want to calculate the length of AB. Now because of we had that line OE being perpendicular to AB, we can see that that line was also bisecting EA and EB, right? So the first thing that we're going to do here is we're going to say, number one, we're going to say AE is equals to EB, right? And the reason for that, it will be the line from center perpendicular to chord, right? Now because of we have that, we'll then after then we'll say here we know that OB, it is what? A radii, right? Or it is a radius, but then now we're going to be equating this radius with radius OD, and then the reason for this one, we'll say these are both radii. Now the reason why I'm doing this is because we want to make sure that we get the information that is going to be enough for us to calculate this side for EB, and then we know that if we have EB, it's going to be the same as EA, and we'll just twice that to get AB. All right, so now we know that here this is 5 centimeters, so now we just need to therefore say that OB, it is 5 centimeters, and therefore I'm going to say in triangle. So right here I'm going to say in triangle OEB, we can see that EB squared plus OE squared equals to OB squared. Now we want to calculate what? We want to calculate EB squared. So this is going to be OB squared minus OE squared. Now EB squared, we're going to substitute the value for OB, that is 5 squared, minus, now the value of OE we were given, it was 4, so squared. So when now what we're going to do is we're going to press this into our calculator. So 5 squared minus 4 squared is equals to 9, and then from here just going to put square root both sides, then EB will be 3 centimeters. Now remember, we're not looking for EB, but we're looking for AB. So AB will then be the length of AE plus the length of EB. Now we know earlier we did say that AE was equal to EB. So now we're going to say AE is 3 centimeters and EB is also 3 centimeters. Now this combined gives us what? Gives us 6 centimeters. And that's how we finish our first question. Now let's go ahead and go into our next question. Now, in our next question here, we are given the following question here. So let's go ahead and look at what is happening here. So here in question 4, it says, now in a diagram below, points A, B, C, and D lie on a circumference, as you can see there, of a circle. Now FG and FD are tangents to the circle at C and D respectively. Now CD is produced to meet AE at E. Furthermore, angle GCH is equal to 78 degrees, and angle CBD is equal to 41 degrees, and angle BDA is equal to 34 degrees. Now, what I've just done now is to just read all of that, and I know that it is a lot of work, right? That is why now what we're going to be doing here is I'm going to be teaching you how to actually dissect all that information and write into an information that is going to be working for you. Now, in order for you to do this, we're going to be doing something called doctor. So I'm going to write it as DRCPT, right? Now, the DRCPT, what does it stand for? So the D here stands for the diameter. So here we're going to be focusing on all the theorems that are having diameter. And then now this one here, it's going to be focusing on the radius. And then with this one, we're going to be focusing on the cyclic quad. And then here we're going to be focusing on parallel lines. And then finally, this one we're going to be looking at tangents. Now, with Euclidean geometry, one thing that I can tell you for sure is that it has a lot of theory. So now this thing, the Doctor CPT or DRCPT, it helps you to dissect all of that, right? So the first thing that I'm going to do here is I'm going to ask myself, do I see any diameter here? So it means now here I do not see any diameter, and I was not told that was there any diameter here. So it means now this one is out. So if there's no diameter, then there's no radius, right? Now, what about the cycle quad? Now, the cycle quad here, there is one here, right? So it means here, I'm just gonna say here, cyclic quad, right? Now, the cyclic quad, what am I looking for? On the cyclic quad, I'm looking for three things, right? I'm looking for two opposite angles that are gonna be supplementary or add up to 180, or I'm gonna be looking for angles on the same segment, and then thirdly, I'm gonna also be looking on the exterior of a cyclic quad. So I'm gonna start with the first one. So the first one that I'm gonna be starting with, it is going to be number one, two opposite interior angles, right, of a cyclic quad. So which ones are going to be that? So now here, firstly, I'm going to look for my cyclic quad. So A, B, C, D here. A, B, C, D is my cyclic quad. So all of those lines, those are my cyclic quad. So now here, the first thing that I'm noticing is that A1 plus A2 and C2 plus C3, they add up to 180. So I'm going to be writing that. So now here, A1 plus A2 plus C2 plus C3, I know these, they add up to 180, right? And then now what's the next one? It is B1 plus B2 plus D2 plus D3. This adds up to 180. All right, so that is going to be the first part that I see about the cyclic quad. Now, what is the second thing? Like I said earlier, the second thing, it is called the angles on same segment. Now, I like to call it the butterfly shape, right? Why am I calling it a butterfly shape? Because it is something of this manner. So it can be like that, or it can be like that, right? So for me, this it looks like a butterfly like that. I'm not sure if that's how butterflies are drawn, but it's something along those lines, right? So with this one here, the butterfly effect will be, or the butterfly shape will be this angle being equal to that angle, right? So I'm going to start there. So I'll say B1, I can see it is equal to A2, right? And then the second one will be this one. Let me use a different color so as not to confuse each other. So this one is equal to that one. So I'm going to write it as C2 equals to D3, right? And then I'm going to flip my butterfly and focus on these two now. right? Now, most of the time, people, they tend to miss those ones, right? So I'm going to write them on this side, this one. So I'm going to say A1 equals to D2. And then, of course, the last part will be that one and that one, right? So there will be B2 equals to C3, right? Now, this is something that is very, very important when it comes to Euclidean geometry, to make sure that when you're talking about something, you find all the angles, because once you find all the angles, it becomes much more easier for you to solve, right? But then you will see as we continue with this method here. So now here again, just to do a quick recap, the idea here that we're doing here is to find all the angles, because we read the instruction and when we saw that there's actually more than what the instruction has been giving us. So now we're using DRCPT to actually help us find all of that, right? So now here we still busy with the cyclic quad. So the third one, it is going to be the exterior of the cyclic quad. Now the exterior of a cyclic quad is always equals to the opposite interior of the angle in that cyclic quad, right? So now here we can see that in order for you to find an exterior, you need to be also very careful. An exterior, it means now that when you have your cyclic quad, for example, let's say here I have my cyclic quad like that, right? Now an exterior will be a line extended from these lines here. For example, in this case here, you see this line DE. DE is an extension of CD. So this then means now D4 is the exterior. But A3, on the other hand, it is not an extension of CA, because an extension should be something into that line, right? So which means now here when we're talking about the exterior, I've already mentioned it, it is going to be D4. Now D4 is going to be the equals to an angle that is an opposite interior. What angle would that be? So it will be that angle there. So D4, it is equals to B1 plus B2, right? Now these are the angles that we found for the cyclic quad, and so now we're going to move on into the next part, which is the parallel lines. Now we don't have any parallel lines here, but then now lastly we do have what? We do have a tangent. So we were told that FG and FD are tangents, right? So let's go ahead and talk about that one. Now when we're dealing with tangents, right, we know that there are three theorems about tangents. The one of them involves radius, but then now here, because of we didn't have a radius, so we're not going to be focusing on that. So the first one, which is going to be a famous one, is what we call a 10 chord theorem. Sorry about that. A 10 chord theorem, right? Now, a 10 chord theorem, how does it work? Now, the easy way that I always teach people how you actually find a 10 chord, it is to actually first locate a tangent, right? For example, let's first locate a tangent. So here we're told that FG is a tangent. So here I can see that this line here, I'm going to try by all means to trace it. There we go. This is our tangent, right? Now, when you're doing a 10 chord, you need to draw a triangle. Now, this triangle, you draw it in a manner that it needs to touch, all three corners need to touch on a circle. For example, here, I'm going to start with this one here. You see here, CBD. So this is a triangle, right? So this triangle, CBD, like that, and DC. So this is the triangle that we going to be focusing on. Now, because of we have that triangle, this means now this is going to be a 10 chord, or a 10 chord can apply here. Now, how does it apply? So a 10 chord states that if we have an angle formed by the tangent and one side of that triangle, in this case C1, that angle C1 is going to be equals to an angle opposite this side inside the triangle, which is that one there, right? So this means now here in this case, we can then see that C1 here, it is the same as D2, right? Now, the same is true on the other side, right? The other side, we have C4 here, right? C4 is going to be equals to B1, like that, right? So C4 is equals to B1. Now where did we get these? We got this on triangle CBD. So I like to mention the triangle because it helps us when we actually going back into finding our answers. It helps us to understand why we did what we did, right? So now we're done with the first triangle. So it means now we're going to go into the second one. Again, how do we look at the second one? We start on our tangent. See here, I have a line there starting from a tangent going to that corner. So it's touching the circle, this other corner touching the circle, and that other corner touching the circle, right? So which means this triangle here is a valid one. So let me also highlight it again like that. All right, now what do we see here? We see an angle formed by what? This angle is formed by the tangent and one side of the triangle. What is that angle? That angle is C1 plus C2. This angle, it states that it is going to be equals to an angle that is opposite the side that formed an angle with the tangent. In this case here, this is D2 plus D3, right? Then now the same is true on the other side, C4, right? We have a C4 here. We're saying this is equals to an angle opposite, right? Or angle facing that side that is created an angle with the tangent. And then this came from what triangle? Triangle CAD, right? Okay, so now, which means we're done with this one. So now we can see, do we have another line? So we don't have another line here because this line, it gives us back the triangles that we have already worked with, right? So which means now we are done with this tangent. Now, were we given another tangent here? Yes, we were given another tangent. So another tangent was tangent FD, right? So now, how does the tangent FD work? So with tangent FD, we're going to be doing exactly the same thing, all right? So what are we doing on this side? We're going to be taking a line, for example, here. You can see here, I can show the line from there and there and then back here, right? Now from this here, I can see that I can form a triangle there. Then all of the three corners, they are touching the circle, right? So this means now what we're going to do here is we're going to look for an angle formed by the tangent and the side of the triangle. In this case, it is D1. So let's go ahead and write D1 here. So I'm going to write D1 there. So D1 here, it is equals to, again, the angle facing that side that formed an angle with the tangent, which is in this case A2. Now, is there another side here? No, there's no side on the other side because this tangent didn't extend, it just ended there. So because of that, it means now we are done with this triangle. So now we're going to look for another triangle. Is there another triangle here? Let's see. Now I'm going to focus, or I'm going to trace on this line. You can see that when I'm tracing this line like that, it gives me this triangle, right? So now again, this angle D1 is the same as that angle B1. Alright, so which means here we will say D1, it is the same as B1, right? And then this is in triangle. The first one was in triangle. Sorry about that, just mentioned the triangle here. So the triangle there was triangle CAD, and then this second triangle, it is triangle, sorry, not CAD. Remember, when you name the triangle, it is easy to start from where we started our triangle, which is the D part. So DC, let me write this, DCB. All right, let me see here. We said here CBD, so it is okay, CAD, so that was perfectly fine. All right, now these are the angles that we can actually find from our diagram. Now remember, we were also told that there were angles here that we were given. So which angles are those? So we're given angle GCA. So angle GCA, that will be this angle here. So they told us the value of this angle is what? it is 78. So we are going to be using that. So let's go ahead and note that one down. And then what's the next one? CBD. So CBD, it is 41. So this angle, it is 41. And then what's the next one? BDA. So BDA. All right. BDA. So angle BDA, it is 34. That is weird. Let's see. It's 34. Now again, let's double check here. We're told that GCA. Oh yes, GCA. It is this one. Now I understand. I made a mistake on the first angle. The first angle, it is GCA. So the whole angle there, it is the one that is equals to 78, like that, right? Because now I was so confused. I was like, how can now C2 be 78 and 34 be D3, right? Now it makes sense. All right. So now we have all of those angles. So let's go ahead now and answer the questions. Now, what I like about this method is that when you're answering the questions, now it becomes very easy, in a sense that what you do is you look at the question that they're asking you to do, right? And then you go back into your instructions and then find all those angles that are equal to the one that they want you to calculate, right? For example, let's look at this one. So here it says that let's write down with reasons three other angles that are each equal to 41, right? So now here we know that we are given, right? We know that we are given that B1 it is 41, right? So now they want us to find other angles that are equals to 41. So how do you find other angles that are equals to 41? So basically what you do is this. You look on your instructions here, or what you were given here. You look for what? You look for B1 here. So now here we can see there's B1, the first one here. I can see that angle D1 is the same as B1, which is 41. So what was the reason here? If you remember the reason here, it was the tan chord, because we're talking about tangents. So it's a tan chord theorem. So everything here is just come out naturally. So now if we have D1 as 41, which means now we're gonna go there and write 41. So that's the first angle that we have, right? Then now we're gonna check now if we have B1 is 41 and D1 is 41. Now we're looking for both, right? We're looking for B1 and also we're looking for what? We're looking for D1, right? So now here I have B1 here, and I'm told that B1 is equal to C4, so which means I'm gonna write that C4 is equals to B1. It is 41. Same reason, tan chord theorem, right? And then now I have ways that is C4, so that is 41. So now I need to find another 41. Let's see. Oh, there you go. So now I have three angles, C4, D1, and B1. And then by luck, I can see here I have C4 being equals to A2. So which means now A2 is equals to C4, which is equals to 41. What's the reason for this one? Same reason, tan chord theorem, right? And then with that, you can see that we find all three angles that are equals to 41. All right, now let's go ahead now and look into another question and see how do we actually use these answers or the information that we're given to our advantage now. So 4.1.2, it states that now we need to determine with reasons the sizes of the following, right? So they're saying now we need to calculate D2, right? So we need to find, question A, we need to find D2. Now how do we find D2? So this is how. We're first going to go into our instruction and find where we can see where do we find D2, right? So I can see that I have D2 here, I have D2 there. Okay, I don't have D2 on the other side. Let's see here, D2, D2, I have D2 there, right? So now what we do is this, right? We're going to look for a value that an equation out of those three that gives us an actual value for D2, right? So for example here, this tells me that A1 is equal to D2, right? And also here this tells me C1 is equal to D2, right? So it means now here I can easily take one of those ones. Doesn't matter which one is it, right? So let's say, for example, let's say I take C1. So let's say I say C1 is equal to D2, right? So what will be the reason for that? So I'm going to go back to the reason where I got this. So the reason was the 10 chord. So it means now here I'm going to write this is a 10 chord theorem, right? But now the question is this: what is the value for C1, right? Because now I need to understand what is C1. Now by the looks of things here, I can see that C1, when you add it with C2, right, it gives me 78, right? Okay, so now here I can say now, but C1 C1 plus C2 gives me 78, right? So this was what? This was given, right? So this then means now that C1 it is 78 minus C2, right? Now, what is the value now of C2? Because now I need to know what is C2 in order for me to understand what everything here. So which means now I'm going to be looking for C2. So C2, we were told that it is equal to D3, and then the reason was angle on the same segment. And if you remember, we did find what D3 was. You remember, D3, it is 34, which is something that we're given, right? So now, which means now, therefore, we're going to say C2, it is equals to D3, which is equals to 34, and that was because of the angles on same segment, because that's where we got this one. And because of that, we're then going to say, therefore, C1 will be 78 minus 34, and then C1 will be, take our calculator, 78 minus 34, then this gives us 44, right? So we have 44. Now we're gonna go back into what we have. So now here, I'm just gonna do a little update here because I like it when I have it like that. So this is 44 and that is 34, right? I know that they still give me 78, but it's just that they are broken down now. So now, where were we? We have C1 is what? As 44. Remember, we were calculating D2. So D2, we said it is equals to C1. So therefore, D2, if C1 is 44, this means D2, it is also equals to 44. Now let's go ahead and look into the second question. So the second question, that will be B2. So what are we going to do with B2? We're going to do literally or exactly the same thing. So we're going to go back, go to our instructions. So I want to remove this. Let me remove that. Okay. And let me also remove that. So now we're looking for B2. So it means I'm just going to highlight everywhere where I look for B2. But more especially, you always need to focus on the ones that give you a straight answer. You see here B2, which is the one we're looking for, it is equal to C3. So it means now, is there another thing that gives us that? So there isn't. So it means now here, in order for us to calculate this one, we're going to say B2 is equals to C3, right? Now what is the reason for that? The reason is going to be angles on the same segment, right? So now angles on the same segment, then it means now we'll have to then ask ourselves what is the value for C3. So let's go ahead and see. Do we have C3? Actually, we don't have C3. So now can we find C3? Because we also don't have C3 here. Let me see here. We don't have C3 here. No C3. And also here, no C3. So which means now we need to calculate C3 on our own. So now how can we calculate C3? We can just add all the angles here. And then we can see that they add up to 180. So which means now here, we can then say now to find C3, we're going to say C1 plus C2 plus C3 plus C4 equals to 180. So these are angles on the triangle. So therefore, this means C3 is going to be 180 minus C1 minus C2 minus C4. All right. So C3 then will be 180 minus C1 was 44 44 minus C2. Remember C2 was 34, and then C4, I think it was 41. Yes, it was 41. And then we're just going to press all of that into our calculator. So let's see, 180 minus 44 minus 34 minus 41 gives us 61. So it means now C3, it is 61. What do? We go back into our diagram. It always updates because everything that we get here, it helps us, or it will help us. So I have 61, right? Who knows, maybe they might want us to calculate D4 or D2, you know, like for example here they want us to actually calculate D4. Oh, all right, so let's see, they want us to calculate D4. So what are we going to do? We're going to do the same method. Now the idea here is always the same. You look for D4 here. If you can't look at it or you can't find it, see how you can basically get D4. But then now here by luck, here we can see D4, it is B1 plus B2, right? So I can see D4, it is B1 plus B2. Now let me see, do I have B2? No, I don't have B2, but I can find B2, right? So D4, it is B1 plus B2. Now what was the reason for that? So let's go back there and see. Okay, exterior of a cyclic quad. So the reason for this was the exterior of cyclic quad. Now D4 equals to, we're ready for B1. Let's see B1. B1 is 41. So I'm going to write 41 plus B2, right? But what is B2? So now it means I need to find what B2 is. So going back there, looking for B2. B2, where are you? There is B2. So B2 is the same as C3. The reason for that, angles on same segment. So which means I'm going to say but B2 equals to C3, and the reason for that is going to be angles on same segment. All right, then now C3, I think we did mention C3, it is 61. So which means now what I'm going to say is that B2 it is equals to 61, right? So therefore D4 is going to be 41 plus 61, and that will be 102. So D4 will be 102, and that is how we find D4. So I'm gonna update that 102. So what's the next question? The next question, it says let's calculate the angle for F, right? So D, we're gonna be looking for angle F. Now angle F here, I can see that here I have D1 plus C4 plus F, which they actually sum up to 180, right? So I can say F plus D1 plus C4 equals to 180. So these are interior angles on triangle. So let's just say CDF so that it can be clear. So now F here, it is equals to 180 minus D1 minus C4, right? Now D1 and C4 are equal, right? So but you're gonna say D1 and C4 are equal. So this one is because of two tangents or two tangents from same point, right? Given that when they are at the same point, CF becomes equals to FD, right? So CF is equals to FD because both of them are tangents and then they intersect there. So because of they are both tangents, it means they are equal. Now because of they are equal in triangle, it means also their angles are going to be equal, right? So now when you go back then into the question, you will notice that we both have 41 and 41, right? Hence the theorem there, right? So then say angle F is going to be equals to 180 minus 41 minus 41, and then angle F will be, press calculator, 180 minus 41 minus 41, so that will be 98, and that will be a value for angle F. Right, now let's go ahead and look into the last question. Now the last question here, it is the 4.1.3. So now it says, now determine with reasons whether CADF is a cyclic quadrilateral or not, right? So we're looking at CADF. So we need to prove whether CADF is a cyclic quad. All right. Now, when you're proving something that it is a cyclic quad or anything, right? For example, if I'm proving that a triangle is an isosceles, right? What I need to do is I need to pretend as if it is an isosceles so that I can find its properties, right? So now here, they want us to prove if CADF is a cyclic quad, right? So now for me, in order for me to answer this, I will first pretend as if that it is a cyclic quad. So if it is a cyclic quad, or if it was a cyclic quad, what is it that I would have taken out of this diagram, right? So number one, I would have said, for example, that A2 plus F is equals to 180. Those would have been the two opposite interior angles of the cyclic quad, right? So this is the only thing that I can use to prove that, right? What's another way actually that I would have done? I would have taken C3. For example, C3 plus C4 plus D1 plus D2 plus D3, that I would have tested it, or I would have concluded and said it is 180. Now another thing that I would have said was that C1 plus C2 is equals to, is an exterior, right, which is then equals to D1 plus D2 plus D3, right? So now when we're proving whether this is a cyclic quad or not, right, we need to get one of these things right? And we need to just take one. If we get it, one of them is wrong, it means it is not a cyclic quad. But if we get it right, it means it is a cyclic quad. So now with this one, the first one, it is enough for me to prove this because I know the value for A2. Let me just go back there. If you remember, F was 98. So I have 98 here, for example. So I know the value for A2. I know the value for angle F. So if I just add both of them and then I don't get 180, then that means it is not a cyclic quad. Now angle A2, going back there, it is 41 and the other one is 98. So I have 41 plus 98. Now when I add this, what do I get? Let's see, 41 plus 98, I get 139. So 139. So is this equals to 180? No, this is not equals to 180. Now because of that, CADF is not a cyclic quad, and that is how you're gonna be finishing with these questions. And that's all I got for you today in this video. Now if you basically enjoying what you basically listening to, there are gonna be there is a course that I'm going to be running starting today. And in this course, basically what it's doing is I'm going to be going through the March exam preparations, right, where I'm going to be taking you through the preparation on how you can prepare for the exams, the topics that you would have covered, since it's going to be the ones that you're going to be writing on the first term. Now I have a poster that I would like to basically explain how this thing works. So let us go ahead and actually jump into that poster. Now looking at this poster, you can see that here this is basically the March exam lessons. So where we're going to be doing lessons online. Now the registration fee is that this is only for learners that are South African learners or learners that are following the CAPS curriculum. And then the registration form, it is 200 or 300 rands or 300 South African rands once off, and then this is for 10 lessons. Now the sessions will be starting on the 4th of March, and then the classes are going to be going through at 6 p.m. South African time. Now the topics that we're going to be covering on those 10 lessons for grade 11, it is going to be equations and inequalities, exponents, trigonometry, and Euclidean geometry. And then for grade 12, it will be trigonometry, Euclidean geometry, sequence and series, and functions and inverses. Now to register for grade 11, all the other do is to basically type in this link here, but for grade 12 you need to type in for this one. Now the registrations are going to be closing on the 3rd of March 2024. because the sooner we get that, that's when we're going to be starting. Now, the nice thing about this is that you don't have to actually attend all of the classes. If it happens that there's an emergency, they are going to be recorded sessions, and then those sessions, it will be your responsibility to go back and watch them so that you can be able to track that. And also another thing, these topics, you don't have to study all of them. You can only focus on the ones that you're going to be writing. These are the ones that I was able to pick it up based on my research that I've done, and I'm going to leave it at that. So that's all for this video, and I'm going to see you into the next one. Cheers.